Hello and welcome to GrossiMath.com, where math is for everyone. Today we'll be solving question 7 from the 2017 Algebra 1 STAAR by hand using two methods. So let's get started. Okay, so as I said, there were two methods of solving this equation. The first one I'm going to do is based on the fact that it's multiple choice, and you'll see it's a quick way to get a solution if you're just studying for your STAAR. The second way that I'll do it is for people who are really interested in learning like high-level mathematics, and they can solve this without it being a multiple choice question. Okay, so if you're interested in learning a little deeper, watch the second half of the video. But for the first half, let's get into it and just figure this thing out. Okay, it says the total number of seats in an auditorium is modeled by a function where A represents, and that's an important keyword, A represents the number of rows of seats. Okay, so we have a number of rows of seats in an auditorium, which is represented by the letter A. Okay, and how many rows are there in the auditorium if it has a total of 84 seats? Okay, so the other number that we're tracking here is clearly seats. Okay, and that is represented by G of A. Well, what do I mean by G of A? Okay, well, what G of A basically means is I can put in any A that I want into this little expression right here, and it's going to produce an answer, and that answer is called G. So basically what G of A means is if you put in a number, what comes out? If you put in a different number comes out, but it's based on the original number. Like that's the number that's influencing it. So you drop in the A, whatever number it is going to make that G happen. And then if you drop in a different A, you would get a different G. And if you drop it in a different A again, you would get in another different G. And basically that's why they call it G of A. In other words, if you plug in some specific number, what number would come out? That's called a function, and that's why we write it this way. It just means that the G depends on the A. Okay, so let's go ahead and do this problem. The first thing we can see is that we need an answer that produces a total of 84 seats. So the 84 is going to go right here, and what they're asking is how many rows. So we need to fill in a number here that will produce 84 seats. In other words, which A will make the number 84? Okay, so this is very simple to do. All I'm going to do is go in my calculator, and you can do this with any calculator. You don't have to have the TI Inspire. All I'm going to do is take my original function, and I'm going to replace the letters, the variables A. I'm going to take this side of the expression right here. Let me take off that arrow so it's not confusing. I'm going to take this side of the expression and I'm going to copy it. But instead of copying the letter A, I'm going to put some parentheses instead of A. So parenthesis squared. Minus 2 parenthesis. And there we go. And now you can see, and I'll even zoom it in a little bit so that you can see it clearly. So let's zoom in here. There we go. Okay, and you can see that there are some parentheses there instead of the letter A. And all I need to do now is go in my calculator and start plugging in the numbers that I actually want to use. Well, the first number we want to test is the number A, because this is a multiple choice question. So we're going to test, no, I'm sorry, not the number A, the number 8. The number 8, because this is a multiple choice question. So here I'm going to put an 8 into the calculator in that parenthesis. So let me go in there and type the number 8, and then here put the number 8. Again, you don't need to have a TI Inspire to do that. You can do that with pretty much any calculator, any scientific calculator, and that's usually what you have access to on the STAAR. If you don't have access to one, you could do this by hand, right? I mean, this problem right here that I've just created for the calculator to do is basically a PEMDAS problem. So if you had done that in middle school, you would have been able to do it by hand. So we press enter, and there we go, 112. Okay, so the number 8 produced the number 112. Well, let's take a look at what I just wrote down. There we go. So the number 8 produced the number 112. Well, that's clearly wrong. Do that with blue instead. That's clearly wrong. I want a number that produces the number 84. So now we're going to go up inside the calculator and just copy and paste that piece. Again, you could just rewrite it. It doesn't matter. Now when I copy it, someone's going to say, what happened to my parentheses? And you're right, the parentheses did disappear. However, the parentheses are only there for the calculator to decide if it needs them or not. They prevent errors, but they're not essential. If the calculator takes them out, it means it did not need them. So always use them when you type the equation at first. But if the calculator takes them out, that's okay. That means it's decided now what it's going to do with those, and it's done with parentheses. Okay, so now I just need to change my 8s to the number 7, because 7 is option B. So I'm going to change my 8s to 7. Again, someone's going to say, where'd you get that number 7? I got it right here. Okay, that's the number 7 right there. And that's the number I'm testing next. So I push enter, and look, the number 7, when I put it through the little function machine here, when I plug in a 7, the G pops out as being the number 84. And therefore that is correct. So 7 is our correct answer. Okay, so that's the end of this problem for those who are only interested in a STAAR practice strategy and learning how to do it longhand using multiple choice as kind of an elimination strategy. However, what if this wasn't multiple choice and I wanted to solve it? Well, stay tuned if you're interested to know. If you're not, well, that's okay. You can stop watching here, but don't forget to like and subscribe. Now, in the second half of the video, for those who are still here, I'm assuming that you're interested in seeing how to solve this without it being a multiple choice problem. So let's get to that. The first thing we can do is take away our calculator here, because we're not really going to need it very much. And then we can erase all of that. And I'm going to try to read this as if someone skipped ahead, because maybe someone did skip ahead to just get to the second half of this video. So let's try to catch everybody up just in case. Okay, it says the total number of seats in an auditorium is modeled by a function where A represents the number of rows of seats. So there are two numbers here. There's A, and that represents rows. And then there's G of A, which represents seats, the total number of seats. And once again, we are interested in how many rows. So how many rows? We need a number that goes here. How many rows are there in the auditorium if it has a total of 84 seats? So there are 84 seats. And we're going to put that 84 right there. So we need a number that will produce the number 84 for our function. Now, obviously, again, this second half of the video, I'm going to go a little bit more advanced. And there are two things that you need to be familiar with to understand this. Well, technically three, but for the most part two. Quadratic equations. Okay, specifically, I want you to know about standard form and the quadratic formula. Okay. The other thing you have to know is some basic algebra rules, but I'll get into that once we're solving it. Okay, so step 1, copy my function. G of A equals 2a squared minus 2a. Okay, now I know that I want to produce the number 84, so I'm going to just exchange G of A and make it 2a squared minus 2a. Now for those who really like math, to be honest with you, I do a little thing where I like to flip an equation so that my variables are on the left. I just find it easier looking. I don't know why, but it's just psychological with me. So I'm going to do that step. And now this 84, what I want it to be is the number 0, because if you know about quadratic equations, you know that it's very useful to set them equal to 0. So what we can do is we can do 2a squared minus 2a equals, minus 84 equals 0. Now, if somebody's still hanging in there and just trying to be a little ambitious and watch this and said, how come you made that 84 a negative 84 now? Well, if you're interested in knowing more about that, please go and watch the video for the by hand video for solving question 11, and you'll see the skills that you need to understand how that 84 became a negative 84. Okay, I would explain it here, but it will make the video take forever, and I don't want to do that to you guys. So if you're interested to learn a little more, go back and watch question 11 by hand video. But for now, let's keep moving. Okay, so now I have a quadratic equation. And the next step that I'm going to do is basically to say, look, this is a factor of 2. This is a factor of 2. This is a factor of 2. So, or a factor of 2. This is a multiple. This is a multiple of 2. This is a multiple of 2. And this is a multiple of 2. So I can divide this by 2. I can divide this by 2. I can divide this by 2. And if I divide the whole side by 2, all the terms are being divided by 2, so that's the whole entire side. I'm also going to divide the right side by 2. Again, if you're wondering why that happened, question 11. Okay, so now we're going to go ahead and we're going to simplify. So basically, what did I do? I divided this by 2, this by 2, this by 2. So now I'm going to get a nice simple little quadratic equation. A squared minus 1a. Let me not put the 1. It's bad form. A squared minus a minus 42 equals 0. Okay, so now I have a quadratic equation. It is in what is called standard form, and I hope you know about that from class, from whoever your algebra teacher might be. And now I'm going to use the quadratic formula. Well, the quadratic formula looks like this. Okay. If this is the first time you're seeing this, you're going to have to do some research and find out where did it come from. I haven't made a video for it yet, but I probably will eventually. Anyway, or you can just ask your teacher. Okay, so do not get confused. This letter A does not match this letter A. This is just a formula. Okay, so in a formula, sometimes we use letters that pop up in our equations, and that's not meant to confuse anybody. It's just something that happens randomly once in a while that we happen to choose the same letters. It's inconvenient though, so I'm going to just illustrate that this A, which I will underline with brown, basically represents the coefficient of the quadratic term. So that A right there is going to be this 1 that's in front of that. Now the B, that B right there, is going to be that -1. And then that C, well, that C is going to be that -42. Okay, and there we go. So here I have my 3 pieces, the A, the quadratic formula A, the B, and the C. Okay, and all I'm going to do is take those and substitute them into the quadratic formula. Well, what this means, this X is going to be the rows from my equation. So I'll say the red A equals, and now I'm just going to substitute into the quadratic formula. Okay, negative B. Well, B is -1, and the negative of -1 is +1. Okay, plus or minus the square root. B squared. Well, -1 times -1 is +1. -4AC. So that means -4 times the brown A, which is 1. Why did I write A? I don't know. Which is 1. And the letter C, which is green, -42. Okay, well, multiplying with 1 doesn't do anything, so I can scooch that guy out of there. And I'm going to have negative times negative makes positive. And 4 times 42 makes 168. So that's going to be plus positive 168. And now down here, I have again my brown A. So that's going to be 2 times A. 2 times A. And that brown A, 2 times 1 makes 2. Okay. So now we have pretty much everything we need. Now we're just going to simplify. So we're going to get A equals 1 plus or minus the square root of 169 divided by 2. Okay, so now I can get rid of my little scratch paper area here. And now we're just going to simplify this even further. A equals 1 plus or minus. Well, the square root of 169 is 13. 13 times 13 makes 169. So the square root of 169 is 13. And then we're going to put that over 2. And just to double show you, You could, if you don't know your square roots by heart, and to be perfectly blunt, I double checked this before because I was confident, but I wanted to double check to make sure before I made this video. You could check it in a calculator. So let's do that. I'll go to my calculator here, and I'll put control and square root and 1, 6, 9. And there you can see it makes the number 13. Okay, so anyway, let's get rid of our calculator now. So we'll switch that off. Click. And now we have a really easy problem here. Okay, so there are two possible answers because this is plus or minus. So we need one for if there was a plus sign and one for if there was a minus sign. So we're going to make our brackets. That means we're making a list. 1 plus 13 is 14 divided by 2. And then 1 minus 13 is negative 12 divided by 2. All right. 1 minus 13 is negative 12. Yeah. Okay. So, and now we simplify. 14 divided by 2 is what? Well, it's 7. And negative 12 divided by 2 is negative 6. Okay. So there we go. Everything seems good. Now, which one am I going to choose? I have two possible answers here, 7 and negative 6. Well, first of all, negative 6 isn't even here, but positive 6 is here. So maybe they're trying to trick you. If you know about quadratics, you should know that that means that the roots of this quadratic are at negative 6 and positive 7. That's what we just found using the quadratic formula. Where does it cross the x-axis? So this graph is going to look like this. Okay, or actually like this. There we go. Okay, so what we're going to do is this a realistic number if I'm counting rows? No, this is not a realistic number if I'm counting rows. Which one seems more likely? Hey, that auditorium has negative 6 rows? No, that doesn't make sense. That does not exist in the real world. The number 7 obviously would fit better. Hey, there are 7 rows in the auditorium, so of course you're going to choose positive 7 because it exists in physical reality. The problem here is that, or not a problem, but the concept you need to understand is negative 6 exists in the mathematical concept of this function. In the quadratic function that this would graph, negative 6 is a point on the graph. But when we talk about real life, we need to eliminate that negative 6 and say, well, we're going to focus on the positive root here, positive 7, because it's the one that would make the most sense in physical reality. There are only going to be 7 rows in an auditorium. There are not going to be negative 6 rows in the auditorium. Okay, so that's how you can solve this problem the long way if it was not a multiple choice problem. Thanks for watching. Okay, so don't forget to like and subscribe and to click the bell icon and to visit the website where math is for everyone, www.grossimath.com. Have a great day.